Dear students, I, Mr. Vishal Saha, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this second video of the physical and chemical properties of fats and oils. In previous video, we have discussed about the physical properties as well as we have seen two chemical properties. One is hydrolysis, other one is saponification. Now, if you have not watched a previous video, you can watch, and if you like the content of this video, you can share and subscribe to my YouTube channel. So let's begin with our today's session. Before that, just we will see what are the learning outcomes of this session. After this session, students will be able to explain physical and chemical properties of fats and oils. Now, third chemical property that is shown by the fats and oils is hydrogenation, which is known as the hardening. Now, when unsaturated plant fats get converted into more saturated and solid fats by catalytic dehydrogenation, oils containing large proportion of unsaturated acids are partially hydrogenated by adding hydrogen in presence of the catalyst. Generally, catalysts that are used are finely divided nickel or platinum to form the partially hydrogenated fat. This reaction is known as the hydrogenation or hardening of fat. Hydrogenation is nothing but the addition of hydrogen, where whatever unsaturated groups are there, these unsaturated groups that is the present in the free fatty acids, they will be converted into more saturated groups. Sometimes we are going to carry out the partial hydrogenation, or sometimes we are going to carry out the complete hydrogenation, depending upon the properties of that oils that are to be required. This process is also known as hardening of oil, since it increases the melting point of the oil, because when unsaturated groups are converted into the saturated groups, fats or oil becomes more solid, and due to which their melting point increases, and that's why this process is also known as the hardening of oil. Now, the reaction is carefully controlled for the partial hydrogenation of double bonds, because completely saturated triglycerides are very hard and brittle. Hydrogenation is used commercially to manufacture vegetable ghee from the cottonseed oil, peanut oil, or the coconut oil. Commonly, this vegetable ghee is nothing but it is known as the dalda. So this is the commonly used in for the various cooking purposes, which is manufactured by hydrogenation of cottonseed oil, peanut oil, or the coconut oil. Now we will see what is the reaction involved in the hydrogenation. Here you can see triolene, which is having the oleic acid as a free fatty acid. This oleic acid is an unsaturated free fatty acid. When triolene, which is one free fatty acid of oleic acid, is consisting of the one double bond. So here we will require 3 double bonds to carry out the hydrogenation reaction. So triolene, when reacted with 3 hydrogen molecules in presence of nickel, they will be converted into the tristyrene. So there will be formation of more saturated groups that are present in the tristyrene, which is consisting of stearic acid. Here you can see as there will be increment of hydrogen is carried out by using this particular hydrogenation reaction. Now further, next reaction that is shown by fats and oils is hydrogenolysis. That is the lysis in presence of hydrogen. The esters of oils and fats can be cleaved by passing hydrogen gas under pressure at high temperatures, which gives hexadecyl alcohol. Here you can see, for example, tripalmitin, when it is hydrogen undergoes the hydrogenolysis, in place of hydrogen it will be converted into the glycerol and the hexadecyl alcohol. So in this way, this particular reaction can also be used to carry out the formation of hexadecyl alcohol. This is about the hydrogenolysis. Then next reaction that is shown by the fats and oils is transesterification. Esters of fats and oils can be converted into simple esters by treating with methanol and the sodium methoxide. Here you can see this particular simple reaction. So esters of fats and oils, this is nothing but the ester of fat and oil, which is known as the triglyceride. So it will be reacted with the methanol in presence of sodium methoxide to get converted into the glycerol, plus there will be formation of simple esters that are formed. Now here you can see first what happens when they undergo, these triglycerides undergo hydrolysis, which leads into the formation of glycerol and the free fatty acid. Further, free fatty acid will react with the alcohol, that is the methanol, which leads into the formation of these simple esters. In this way, this process is known as the transesterification. We are going to carry out the generation of ester from other ester. That's why this reaction is also known as the transesterification reaction. Now, rancidification of oils. Now, double bonds that are present in fats and oils are subjected to oxidation by the air. Fats and oils on long exposure to air and moisture develop disagreeable smell and taste. This phenomena is commonly known as rancidification, because due to the storage of oils and fat, what happens, double bonds that are present in fats and oils, they are subjected to oxidation, and due to the oxidation they will develop a disagreeable smell and taste. So this process is known as the rancidification. This phenomenon of oxidation of fats and oils involves radical chain reaction. In the initiation step, radical removes the hydrogen from a methylene group of fat that is flanked by two double bonds. Here you can see this particular reaction, it is the initiation process, where here what happens, one of the radical that is present, it will remove the one of the hydrogen that is present in the methylene group of the fat, which leads into the formation of the radical ion. Another cause of unpleasant taste is hydrolysis, which is brought about by certain enzymes like lipase, which are mainly present in naturally occurring fats, especially animal fats. The hydrolysis of triglycerides may produce the short chain fatty acids, which have the bad odors. So number of reasons are there why fats and oils become rancid. So few of these are due to the hydrolysis, they will be converted into the short chain fatty acids, and these fatty acids are having disagreeable odor. Also due to the unpleasant taste is also due to the hydrolysis, which is brought about by the certain enzymes like lipase. In order to prevent rancidity, fats and oils should be kept refrigerated and in dark bottles. So this rancidity or rancidity of oil is used to carry out the determination of purification of the oils, because due to the long storage of fats and oils, there will be whatever triglycerides are there, they will be hydrolyzed, so that due to the hydrolysis they will be converted in the free fatty acid, and if the amount of free fatty acids are more, then you can say that the oil or fat sample become the rancid. In addition to this, Antioxidants are often added to fats and oils to prevent the rancidity. It is to be noted that vegetable fat contains certain substances like vitamin E, vitamin C, phenols, hydroquinones, tannins, which are acting as antioxidants, and therefore they prevent the development of rancidity. While animal fats, they are more subjected to the rancidity because they doesn't consisting of any antioxidant material. Also, they are consisting of the more amount of saturated double bonds. Hence, vegetable fats can be preserved for a longer period as compared to the animal fats. The resulting radical reacts. After initiation step, we have seen that there will be formation of radical. So that radical that is formed, it reacts with oxygen, which forms a peroxy radical with conjugated double bonds, and the peroxy radical removes the hydrogen from the methylene group of another molecule of fatty acid, forming the alkyl hydroperoxide. Means radical that is formed after initiation step, it will react with the oxygen, which forms the peroxy radical with the conjugated double bond. This peroxy radical again removes a hydrogen from the other methylene group of another molecule of fatty acid, which forms the hydroperoxide. The two propagating steps are repeated over and over, and the unpleasant taste and smell associated with the rancidity are the results of further oxidation of alkyl hydroperoxide to shorter chain carboxylic acids that have strong odors. Means in last step, alkyl hydroperoxides are undergo oxidation and they will be converted into the shorter chain carboxylic acids, and formation of shorter chain carboxylic acids, this is the reason why the strong odor is developed. The same process produces the odor associated with the sour milk. So this is about the rancidification of oil. Then last property that is shown by fats and oils is drying of oils. Highly unsaturated oils, say for example linseed oil, they thicken on exposure to air and eventually harden to give a smooth and clear resin. Such oils are known as drying of oils. It is widely used in the manufacturing of the paints, varnishes as well as the shellac. Means what happens, the highly unsaturated oils, because they are consisting of more number of double bonds, these oils thicken on exposure to air and eventually harden to give the smooth and clear resin. If acid contains conjugated system of double bonds, for example electrosteric and lichenic acid present in the tung and otica oils, drying takes place more readily as compared to the glycerides containing the non-conjugated double bonds. For example, linseed and perilla oils, which contain linolenic acid as well as the linoleic acids. So this is about the drying of oil. The mechanism of drying appears to be complicated process involving the partial oxidation, polymerization and colloidal gel formation, and it has been found to be catalyzed by various metal oxides. So these are the various chemical and physical properties that are shown by fats and oils. If you have any queries related to the pharmaceutical organic chemistry, you can contact me on this particular mail. Thank you.